So I called it more tree graphs. That's what it is. We're consolidating our understanding of the graphs of the parent functions y equals sin x and y equals cos x and sketching their image functions based on the transformations. So sketch 2 cycles of each of the following. Label the scale on each axis. Draw 1 cycle of the parent function. State the transformations in words. State the amplitude, period, and phase shift. Show mean and range. Okay. So it kind of gives you an order of what to do. Label the axes. So put the scales on. And after you've done the scale, you're going to figure out what your parent function is. So for us, it's sine, so it'll be 1 cycle of y equals sin x. So that starts at 0, and maybe at 1. Once you've done your scale and your 1 cycle, then you ask yourself, are you ready to highlight? And the answer for this one would be no. Good. Okay, so then we would rewrite it in factors form. So I would do Q bracket x plus 60 degrees plus 30. Then I would color code. So the negative sign is 1, the 2 is vertical, and the positive 3 is vertical. And then the 2 in the brackets is horizontal, and the 60, positive 60 degrees. And then I would write them out. I always write them out from left to right. So I would start with vertical reflection. And then vertical stretch by a factor of 2. And then the next 2 is a horizontal compression. By a factor of 1/2. Then the plus 60 degrees is a horizontal shift. Left 60 degrees. And then in brackets, I will put 2 squares. And then vertical shift. Up 3. And actually the most common error is you only go up 3, but you want to go up 6 squares because of your scale. So always make sure you write down the number of squares. And then once you got them all written out, which takes a while, you're going to take your first point and apply it. I see some people have drawn a new vertical axis on. So they know that all of their, all of their points that start at 0 should land on the new vertical axis. It's going to be at 3. So that's a good way of knowing if you're making sense or not. So I don't remember what I have written there, so I'm going to take a picture and read it as I go. Okay. All right, so I go to my graph, and I'm starting with my first point here. Vertical reflection, well, I'm right on the axis, so I can't do anything with that. Or my vertical stretch by a factor of 2. Or my horizontal compression by a factor of 1/2. I can do my horizontal shift left 60, which is 2 squares, and the vertical shift up 6 squares, which puts me right here. Started on the central axis, ended on the new central axis, so that's a win. Okay? Then I go to my next one, vertical reflection, so down to -1. Vertical stretch by a factor of 2, so down to -2. Horizontal compression by a factor of 1/2, so I cut 90 in half and I get 45. Left 60, 1, 2, that's 2 squares, and up 6. 1, 2, 3, 4, 5, 6. So I landed there. Yes? Yep. Okay. Next one. So, can't do the vertical reflection and vertical stretch, but I can do the vertical compression. So 180 divided by 2 is 90. Then left 2 squares and up 6. Got there. So for the 270 vertical reflection, so up here, and then vertical stretch by a factor of 2, so up to 2. Horizontal compression by a factor of 1/2, so 270 divided by 2 is 135. Then left 60, up 1, 2, 3, 4, 5, 6. And then the 360, can't do the reflection or the vertical stretch, but I can do the horizontal compression by a factor of 1/2, so puts me at 180. Left 2 squares is 60, and that's 6. So that should be one cycle. So I want to check and see if there's a pattern, a consistent pattern. So I go over 1.5, down 4, over 1.5, up 4, over 1.5, up 4, over 1.5, down 4. Does that make sense? Okay. So I'm going to draw it in and then compare it to my words. So is there a vertical reflection? Yes, this one goes up first, this one goes down first. Is there a vertical stretch? Yep, it takes up twice as much space vertically as this one does. Horizontal compression? Yep, it takes up half as much space horizontally as this one does. Shifted left, yep, you can see that, and up, yep, you can see that. So now you're just going to follow your pattern and make another cycle. So it's over 1.5, down 4, over 1.5, up 4, over 1.5, up 4, over 1.5, down 4. Okay, so there's my sketch. Amplitude, remember I can get all that stuff right from the equation now if I want to. The amplitude should be 2, the period should be 180 divided by 2, or sorry, 360 divided by 2, which is 180. My phase shift is -60. But I can also find them out off my graph. So my amplitude is from 3 to 5, which is 2. Period. For one cycle, it's 1, 2, 3, 4, 5, 6 squares. Times 30 per square is 180 degrees. My phase shift, it says in the factored version of the equation, is left 60, which you write as negative 60 degrees. My domain, so all real numbers as long as, so leftmost, I'm at negative 60. And rightmost, I'm at 30 degrees past 270, so that's 300 degrees. Oh, thank you.
You're welcome. Good day.
Yeah, you too. And my range, so y is an element of the reals as long as the lowest we ever get is 1, which is less than equal to y, which is less than equal to 5, the highest. Any questions about any of that? How to get any of the specific points? Amplitude, period, or phase shift? Linear range? Everybody's okay for that one? All right, so just one more. Same things we're doing. So start off with labeling your axes. Once you have the scale on, you can see what the parent function is. So cos. And then put one cycle of the parent function on. And ask yourself, is it ready to be highlighted? No? Okay. So we have the factor of the half. So what happens when you factor a half out of a half x plus 120? So?
The same as dividing it by 2.
No.
240.
Yeah, doubling, multiplying by 2, because dividing by half is multiplying by the reciprocal of half, which is 2. So half x divided by half is just x, but 120 divided by half is 240. Very good. Okay. So you can try that on your calculator if you want. Just do 120 divided by 0.5 even, and it'll give you 240. Okay, on the factoring and dividing. Once you've got it in factored form, you're ready to highlight. We've got the 3 is vertical, and the -1 is vertical. The half is horizontal, and the 240 is horizontal. So that means I need four instructions for myself. If I go from left to right and I do the 3 first, that's a vertical stretch. By a factor of 3. What's the 1/2? Horizontal stretch. Good. Opposite of what it looks like. So horizontal stretch by a factor of 2. This is plus 240, so horizontal shift. Left 240 degrees, but I want to know how many squares that is. So I think 240 divided by 30 is 8 squares. And then vertical shift. Down 1, which is 2 squares. So those are the 4 things I have to keep in mind as I'm looking at each point. And my new vertical axis should be at -1. I could highlight that in there if I want to. Okay, so vertical stretch by a factor of 3. So I'm tripling the distance from the x-axis, so up to 3. Horizontal stretch by a factor of 2, I'm still staying in the same spot. Left 8 squares, 1, 2, 3, 4, 5, 6, 7, 8, down 2. So make sure you can get to that spot for your first point. We'll go through it again. Vertical stretch by a factor of 3, so up to 3. Horizontal stretch by a factor of 2, you're still staying at 0. Left 8, 1, 2, 3, 4, 5, 6, 7, 8. Down 1, which is 2 squares. So down 2 squares. The next point, so vertical stretch by a factor of 3, I'm still on 0. Horizontal stretch by a factor of 2 though, so instead of being 90 degrees from the y-axis, I'm going to be 180 degrees from the y-axis. Then I'm going to move to the left 8 squares, 1, 2, 3, 4, 5, 6, 7, 8, and down 2. And I started on the old central axis and I end up on the new one. So that's a good sign. Okay. All right, so the 271, or the 181, sorry, this point here, I have to stretch vertically by a factor of 3, so down to -3. Double horizontally, so 180 times 2 is 360, horizontal stretch. And I'm going to move 8 squares to the left, 1, 2, 3, 4, 5, 6, 7, 8, and down 2. So I've moved the first 3, so now I'm at the 271. So vertical stretch by factor of 3, can't do that. I stay at 0. double 270, so that gets me to 540. Left 1, 2, 3, 4, 5, 6, 7, 8. Down 2. And my last one, so vertical stretch by factor of 3, so up to 3. Horizontal stretch by factor of 2, so over to 720. 8 squares to the left, 1, 2, 3, 4, 5, 6, 7, 8, down 2. So I'm going to make sure I have a pattern before I connect them. So I've got over 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6. That's an easy pattern. Okay, so I've got the pattern. I'm going to connect it now. So, part of a frown, big smile, into a frown. But I have to draw 2 cycles. So this is a good, that's why I put this one on here. So you have to fit 2 cycles in. Yep. I can, yep. So I can go backwards as far as I can. So over 1, 2, 3, 4, 5, 6, down 6. Over 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6. Over 1, 2, 3, 4, 5, 6, up 6. So that's not a full cycle. Does everyone agree? That's 3/4 of a cycle. So how do I make 2 complete cycles? Good. So on this side I have to go do a quarter of a cycle. So 1, 2, 3, 4, 5, 6, down 6. And then I will have 2 complete cycles. That's always a hard thing for people too, is when they can't just go straight like that. So think about, where do you repeat yourself? If you're starting here, 1 cycle takes you all the way from here to here before you start repeating. So there's 1 cycle, and then you start repeating again. There's another cycle. Okay? All right, so now you have to do amplitude. So amplitude is from your central axis to your maximum. So 1, 2, 3. So the amplitude's 3. The period, for 1 cycle, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 24 squares, so the period is 24 times 30 degrees, which is 720 degrees. Phase shift was left 240, so that's negative 240. And it's got degrees with it. And then you have to do domain and range. So the leftmost I went is 2 squares before negative 720, so that's going to be negative 780, because each square is worth 30. And then I go as far as 1 square after 630, so that's 660. And then my range, usually one lowest, I get is -4. And the highest I get is 2. Any questions about any of the points? No, we're good. Okay.